Hi everyone, welcome to the Dynamic Maths channel. Today, we will be learning about trigonometry. Trigonometry is useful in calculating the shortest path to take, decompose forces into several vectors, and help to answer the major question on how to cut the large slice of cake. In this video, I will quickly run through Pythagoras Theorem and explain the three major trigonometric functions, mainly sine, cosine, and tangent, using only right-angled triangles. Pythagoras' theorem states that the sum of squares of two perpendicular sides of the right-angled triangle equals to the square of the hypotenuse. The right-angled triangle is identified by having two perpendicular sides, which is A and B. It is also denoted by having this small square in the triangle. The formula for the Pythagoras theorem is a squared plus b squared equals c squared. Remember, this formula is only valid for right-angled triangles. It will not work for any other triangles. Let's look at some examples. In the first example, we have 3 and 4 and x. 3 and 4 are right-angled sides, and we use the Pythagoras theorem to solve for x. We write down the Pythagoras theorem and substitute the values accordingly. So x equals 5. In the second example, we have an isosceles triangle with a right angled side at the top. Because it is an isosceles triangle, we have 4 here, and the side here is also 4. And we have to solve for x. Use the Pythagoras theorem again. Then you use a calculator to solve for square root of 32. You will get in the third example, we have 8 and 10 and x. We find that 8 and x are the right angle sides, and we have 10 as the hypotenuse. Now we use the formula again and see how the formula works to solve for x. Let's say a is 8 and the value of b is x. Equals c is 10. The value of x squared equals 10 squared minus 8 squared. Solve for x, you'll get 6. These are the few examples how Pythagoras theorem helps in solving right-angle triangles, and this will be useful in solving trigonometric questions in right-angle triangles. Now that we have learned on how to calculate using Pythagoras theorem, let's start with the first trigonometric function, sine. As we are dealing with trigonometry, we have angles to consider. Angles defined on what value should we use to solve our trigonometry questions. For example, sine theta is not equal to sine alpha. To calculate sine of a right-angled triangle, it is simply the opposite over hypotenuse. Let's take sine theta for example. Theta, the opposite of theta is A, and the hypotenuse is C. Therefore, sine theta gives you A over C. For alpha, the opposite of alpha is B, and the hypotenuse is still C. Therefore, sine alpha will give you B over C. Cosine uses the ratio of adjacent to hypotenuse. The formula is cos x equals adjacent over hypotenuse. Adjacent here means next to. So theta here is next to B, which means adjacent to B. Therefore, and the hypotenuse is C. Therefore, cos theta is B over C. For cos alpha, the adjacent side is A and the hypotenuse is C. You'll get A over C. Tangent uses the ratio of opposite to adjacent. The formula is tangent x equals opposite over adjacent. Tan theta will be A over B because A is opposite of theta and B is adjacent to theta. Tan alpha, on the other hand, B is the opposite of theta and A is adjacent to alpha. Hence the answer is B over A. Here are a few examples on how to find sine theta, cos theta, and tan theta. In the first example, we have a right-angled triangle. We have to find the hypotenuse to calculate sine theta and cos theta. Use the Pythagoras theorem to solve it. Write down the formula and substitute the values to solve for the hypotenuse. We find that the hypotenuse is 5. After obtaining the values for all sides of the equation, we can now calculate sine theta, cos theta, and tan theta. Sine theta is opposite over hypotenuse, which is 3 over 5. Cos theta is adjacent over hypotenuse, which is 4 over 5. Tan theta is opposite over adjacent, which is 3 over 4. In the next example, we have an isosceles triangle but not a right angle triangle. We can solve this by bisecting the base to create two right angle triangles. Then take one of these triangles and we notice that one side is missing a value. bisect the base by bisect the base 4 and we get 2 here. The missing value is this side. Use the Pythagoras theorem to solve it. We find that the missing side is square root 32. We have all the sides, and now we can find the values of sine theta, cos theta, and tan theta, which are as follows. Using the same concept as in the first question, sine theta is square root 32 over 6. Cos theta is 2 over 6, which is 1 over 3. And tan theta is square root of 32 over 2. Let's summarize this video. We have learned about the Pythagoras Theorem and basic trigonometric functions based on right-angled triangles. I have listed a summary where you can pause the video and take a screenshot for future reference. If you enjoyed this video, please leave a like, share this video, and subscribe to my channel for the latest updates.